save the world. So I'm now going to introduce our speaker, Dr. Rowan Shaw. I'm very pleased to have him on. He is an artificial intelligence researcher in one of the best teams in the world now, but he's more widely known as the creator of the AI Alignment newsletter and podcasts. So when I caught on to this stuff 15 years ago, there was nothing really, except for maybe a few blog posts here and there, a lot of badly written stuff. And every new article was an event. But now, and this is wonderful, there are many new articles relevant to AI Alignment coming out all the time. It's impossible to keep up with them all. And this newsletter is, again, tying together the community by letting researchers read about all the work that's coming out and letting them follow with it. So now, Rowan, over to you.
Cool. Thanks a lot, Joshua. So today I'm going to be talking about the importance of threat models for AI alignment. So I work at DeepMind. Basically everything I ever do and say publicly is like my own personal views and not those of DeepMind. Just as a standard disclaimer I have to put all the time. One more important disclaimer. I'm going to I don't know if I'll actually say AGI because I dislike the term so much, but I might say it because it's a nice, simple acronym that everybody knows. When I say AGI, I just mean like a powerful AI system. I'm being deliberately vague about the level of power. It might be subhuman, it might be superhuman, it might be subhuman in some areas, superhuman in other areas. Who knows? I don't really want to make any commitments in this particular talk. It's, of course, important in other cases, but I don't think it matters very much for the things I'm talking about here. Cool. So what is a threat model? I think of a threat model as a combination of two things. First, there's a development model that says, what technically do we do in order to get AGI? What code do we write down? Are we using like neural networks? Are we doing something else entirely? Is it GoFi perhaps? And so that part of this, that's like a story for how we get from today to world with AGI or powerful AI systems in general. And then we also have a risk model that says, all right, now we have powerful AI systems, and we need to say how these AI systems do bad things and lead to an existential catastrophe. And I'm going to mostly focus on existential catastrophes here, just from, I'm making that choice, mostly because I, am thinking about long-term effects on the far future. And X risk seems like the most important of those to focus on. Cool. So here's an illustration. So like one threat model, it could look something like this, where we say like the way we get to AGI is we do like gradient descent on some training data, gives us this AGI over here. That's a neural network. And then this AGI happens to act in the world that like makes people very angry with each other. The US and China get, their relationship escalates further, and eventually we get nuclear war, and that kills us all. It's not a very good story, but like, if you could flesh this out and make it sound actually reasonable and likely, or perhaps not likely, but at least plausible, that would, count as a threat model. And then the sort of first two steps on the left would be the development model. And then the two steps on the right would be the risk model. Cool. So that's what I mean by threat model, development model, and like all of them together are the threat model. So that's what I mean by threat model, development model, and risk model. And so in the rest of this talk, I'm going to make 4 key claims that some of them I hope I will justify in the rest of the talk. Others I am hoping you will find obvious, but maybe that won't be the case, and we can discuss during the questions. So first claim, development models are crucial for the solutions that we AI alignment folk are doing. In order for those solutions to actually apply to real systems, we need to have like good development models and tailor our solutions to those development models. It's claim 1. Claim 2, we need risk models in order to find solutions. If we don't have risk models, we're like not really going to succeed at finding solutions. Claim 3. We saw in the previous slide that like the development model and the risk model overlapped in the AGI. And I claim that we should be using the same notion of AGI for these two models, or otherwise our work will probably be irrelevant to what actually happens in the world. And claim 4, we don't yet have a compelling example of a sort of unified threat model where there's a development model and a risk model that uses the same notion of AGI in both cases. And so an implicit to claim 5 is, and therefore we should really work on doing this since it's so important. Cool. So let's get into some justification of these claims. I'm mostly going to do this by like throwing a bunch of examples at you and then coming back to it at the end and being like, look, I'll make the statements again. And based on the examples, they should seem true. So first example, we can think of the utility maximizer threat model. So this is the version that like is in the book Superintelligence, for example. It's been promoted by Eliezer Yudkowsky and Nick Bostrom, or at least this is, I most associate this threat model with them. Though people keep claiming that actually their views are different in some way I don't actually understand. So, you know, take this as my interpretation of the things they say. So in this threat model, you have the way that your AGI looks is that there's some, you know, general purpose reasoning algorithm over here. And this reasoning algorithm is such that you can take some goal or utility function and you can slot it into the reasoning algorithm. And then the reasoning algorithm will spit out a plan that achieves high utility. And so crucially, there's this like separation between like the goal and the like reasoning algorithm or intelligence that pursues that goal. And that's like that's an important, non-trivial, and reasonable decomposition to make in this framework. Cool. So this is our model of like what AGI looks like. And then, you know, the risk model, given such an AGI, is basically captured by the idea of convergent instrumental subgoals, which were listed out in this, you know, classic, I think this is 2008 paper called The Basic AI Drives. And the basic argument is that, well, for most goals, it will be useful, the like plans outputted by this reasoning algorithm will tend to optimize for things like gaining power, surviving or not being turned off, gaining resources like money or social capital, because like these things are all things that help you achieve your goal, whatever your goal might be. Yeah. And so, and so if we get the utility function even slightly wrong, what is likely to happen is that the AI system will, you know, optimize for gaining power over us, for surviving, and we will get sort of catastrophic outcomes. There's like, you know, more detail, but I'll stop there for the moment. And I think, you know, this risk model has been pretty well developed, and I mostly buy it conditional on this like model of AGI. And then on the development model side, we mostly don't have anything. Like there isn't really a story that we can tell that starts from today and then leads to an AGI that looks like this. So at least not one that I find convincing. Cool. So that's the utility maximizer threat model. That was supposed to be, okay. And so with the utility maximizer threat model, it doesn't seem like obviously likely that this AGI will be well described as a utility maximizer in the sense that it's a reasoning algorithm into which you can plug a utility function. Like I don't think humans are well described that way. And And maybe AGI will be well described that way, but it doesn't seem that likely because we can't really tell a story right now by which that is true. So that seems to be a problem with not having a development model. In contrast, since we have a risk model, it's like pretty easy to talk about to generate potential solutions that could avert the risk that we've outlined. So the first one is like, let's not maximize. Instead, we can do some sort of mild optimization or impact regularization so that the AI is not trying its damned hardest to optimize the utility function, but is instead trying to satisfy, get a like reasonably good option. Make 1 million paper clips, but don't destroy the entire universe and turn it into paper clips. So that's like one approach. And then the second approach would be like, get the utility right, the utility function right in the first place. In which case, yes, the AI will, optimize for things like power and so on, but it will use that in order to further human values, which is exactly what we wanted anyway. So there you could try to learn the goal from human behavior. And so once we've, written down this risk model, it like immediately sort of suggests these various concrete solutions we could try. Okay, so that's the utility maximizer threat model. And then we can talk about like deep RL threat models. So in the last, 5 years maybe, there have been a bunch of successes in deep RL. And so a lot of people have taken this as like evidence that we're close to AGI. And so in this model, our AGI is, this neural net that one assumes is taking actions in the real world. We're not entirely sure how it's deployed, but like it's a neural net that's been trained to do cool things. And we have a development model for this. We basically are going to create a sufficiently diverse environment, possibly, similar to the ancestral environment with like a lot of agents roaming around. And then we're going to use the framework of reinforcement learning in order to train an agent to act well in the environment. And the hope is that by doing this, the agent will learn general skills that can then be used to perform arbitrary tasks. And that may not sound convincing just by itself, but I claim that there is, if I could spend another 30 minutes talking about it, it would be more compelling as to why that's a reasonable thing to do. And in support of this development model, we've seen that like this deep RL approach has like led to good results in like Go and OpenAI and Dota, for example. So that's AlphaGo and OpenAI 5. Although the pictures are maybe a bit small to see that. So I feel like the development model side of this is, if not, it's certainly not a slam dunk, but it's at least a plausible approach to AGI. But then on the other hand, with deep RL agents, they're like, fundamentally the way they work is that they try some stuff, and then if it worked out, they do more of that stuff. So it seems a lot harder to tell a story where this, deep RL system takes a treacherous turn, for example, where it like pretends to be good, pretends to be like doing what you want, and then only when it's, when it knows it's able to take over the world does it like show its true colors. That sort of treacherous turn seems like it's not obvious how you square that with the idea of an agent that is, repeating things that it previously saw led to good outcomes. That would sort of be like, I tried out a treacherous turn, noticed it was good, and then decided to do more treacherous turns in the future. It just doesn't really sound very plausible. So on the risk model side, I don't think we have a great risk model in the deep RL case. Another threat model that people have come up with recently for neural networks is language. So there's been, a lot of hype around, well, I say hype. I don't mean that in a negative way. There's been a lot of interest generated by GPT-3 because it is a legitimately powerful and interesting system. And so this has led people to hypothesize that one way we could get to AGI is just by scaling up things like GPT-3. So we have these tasks where we just take simple English language sentences, or well, any natural language. It doesn't have to be English. And then we make these automatic training tasks where we provide part of a sentence and then we ask the neural net to predict what the next word is. And then we do a whole bunch of training with a whole very big diverse data set of language. And we get, this agent that is capable of, for example, turning English commands into shell commands, which that's an example that we have over there. I need to stop moving my mouse. Yeah, so this one, again, seems like a plausible development model. But again, it's not totally clear how exactly this then leads to like, and then all the humans died. It's not obvious how you tell this story. So like, and so I would say the risk model, at least not in a way where the like AGI sort of deliberately caused extinction. And so I'd say the risk model here is again lacking. Okay, so for both the sort of deep RL and language threat models, we've got the development models, and it seems fairly plausible that you get AGI or powerful AI systems this way that are like transforming society. But when you think about, all right, what are the solutions? What are the AI alignment techniques I should throw at these models if I believe they're going to be turn into AGI? It's sort of like not that obvious. We don't really have a story for what goes wrong, and as a result, it's pretty hard to think of solutions. Like it's hard to solve a problem before you know what the problem is. Cool. So I spent all this time sort of dunking on existing threat models. So I figured I should at least try to give my own threat model as someone who is, trying to do research on AI alignment. So I broadly buy the development models in the deep RL and language case, and I'd maybe talk about a slightly generalized version of it, which is sort of this broad idea that we'll have neural networks. They'll be trained on a wide variety of tasks or data of some sort. And due to the limited capacity of the neural net, just because neural nets are small, small in some relative sense. Like they only contain billions or trillions of parameters, whereas the real world has like much, much, much more complexity. And so because the neural nets are small relative to the world or relative to the data set they have to be trained on, they are forced to develop general skills in order to actually deal with all the shit that the diverse data set is throwing at them. This is my explanation for why GPT-3 is so generally capable. And so we do this sort of training in order to develop general skills. And this is just a generalization of the language and deep RL stories, and that leads to very powerful AI systems that we could that we could call AGI. On the risk model side, so how does this actually lead to existential catastrophe? I don't think I can like really give a good outline of this, but broadly, I would say that it's going to be something around bad generalization. So first off, there's going to be some like, big change in the world. And like COVID is a great example of something that would be a like big change in the world relative to what the models had been trained on. And then as a result, the AI system, it's a general reasoner. It's able to like understand that the world has changed and adapt to it. So it generalizes to this new distribution. However, the way that it generalizes is not the way that we wanted. It just it generalizes in a way that's different from what humans would do, but is still high impact. So it like takes impactful actions upon the world, but those impactful actions are no longer doing what we want, and seems kind of bad to be taking impactful actions that don't do what we want. And I claim that this can be as bad as existential catastrophe, but I'm not going to defend that claim right now. Cool. So under this threat model, we can once again ask our questions. How likely is it that AGI arises in this way? It's, again, still not a slam dunk, but I think it is more likely than not. And as in, I do in fact assign greater than 50% credence to this claim. And then what solutions should we be working on if under the risk model that I outlined, where it's bad generalization? Well, first off, we should be training on the right objective. Like, if we're not training on the right objective, there's really just no hope of our agents generalizing in the way that we want. So, the part about like learning the right goal that we talked about before, that's still a thing we should definitely do in this situation. But that's not the only thing. The other ways that we could improve generalization, we could develop interpretability techniques that let us peer inside the neural network, look at its weights, look at its activations, and then say, yes, this neural network, it's got the right concept of like what it means to be helpful to a person, versus, actually, we were trying to train this network to be helpful to a person, but what it learned instead was to do things that made the person stop talking to it because for whatever reason. If we can do that with interpretability, that seems like it could help us ensure that the concepts the neural network learned were actually the right ones and therefore will generalize well, even when the world changes. Similarly, we can do adversarial training, where we train an adversary, which like could be a team of humans or a neural network or something else, to peer into the model that we've trained, the AGI, and look for hypothetical scenarios where the agent would do something that we didn't like. And then if it finds such cases, we can then train the AGI on those cases to like not do the bad thing. And that would hopefully prevent it from generalizing in that particular bad way. Another more speculative one is that we could like really study how the like data sets you train on, the optimizer you use, the architecture you use in neural networks, how that influences how the network tends to generalize. I feel like there probably are actual patterns here that we can figure out in advance. And if we are able to do that, then we could preferentially choose the data sets or architectures or optimizers that lead to the generalization we want. Cool. So yeah, takeaways. I want to go back to our 4 key claims that I wanted to argue for. So first one, development models are crucial for solutions to apply to real systems. So like in the one case where we didn't have a development model, which is sort of the utility maximizer one, I'm like pretty skeptical of the solutions that are proposed in that case, because I don't think they will actually be applied. They will actually like be applicable to the systems we're actually building for AGI. And that's sort of an example of the sort of reason why I think that we really should have development models. Risk models are important for finding solutions. I hope that one seems self-evident now, given that like it feels almost tautological to me that like if you don't know what the problem is, you're definitely not going to be able to find a solution to the problem. 3, we should be using the same notion of AGI for these 2 models. This one also feels like almost tautological. If you have a development model that says we're going to build an AGI of type A, and then you say, but type B and type B AGIs would be bad would like lead to an existential catastrophe. Your argument is not connected. It doesn't matter because the thing you're building is a type A AGI. And if that one's safe, then who cares if type B AGIs are risky for the world? And then finally, we don't yet have compelling examples of these models. I don't think I've like justified this, but I've at least laid out what my beliefs on this claim are. And I don't think you should be convinced by my threat model yet because it was super vague. And yeah, I was very much leaning on intuitions there, and I don't think people should be very convinced by at least that part. Cool. And that's all I have. Thank you so much. Joshua, you're muted.
Thank you. David Mannheim asks, threat models in computer security are generally very fragile to unspecified threats. Does that make the threat model approach worryingly prone to failure? If not, how does the approach you are using differ from what is done in computer security?
I would say that yes, the threat model approach is fragile to unspecified threats. I don't think this okay, I would say that it's prone to failure if you like write down the threat model and then say yes, this is the threat model, and then you no longer think about threat models ever again, and you just try to address the threat model without trying to improve your threat model. That would totally be prone to failure. I would hope that instead of that, what we would be doing is like iteratively building, better and better threat models, and also addressing the threat models that we have. And I guess I don't see how you could do anything else. It feels like the alternative is don't write threat models. The alternative would be something like don't write threat models and try to find solutions that address even unknown problems. And I just have no idea how you have solutions that address unknown problems.
That's the general robustness approach, where you're looking at solutions that address large sets of threats instead of trying to deal with individual ones.
I feel like that is more of a difference on that feels more like what abstraction level you're talking about your threat at. I would say that I don't know, at least the way I would talk about it, I don't know what they do in computer security is if you have a solution that's addressing a set of problems, I would say that there was probably some unifying concept around that set, and you were addressing that unifying concept as the threat model. But perhaps that's not actually the case.
Okay.
I would want to look at an actual example, I think.
Julian Felix Fleury asks, if you think the long-term threat models are vague, does that mean you would put a higher priority on human contingent threat models, like military AI, compared to other AI alignment research?
Yeah, I mean, it depends who you're comparing to. Compared to Miri, probably. Compared to FHI, probably not. So, but I do think they're vague, but I think there's still I think they're vague, but I think they are still accurate, or a good reason for worry or something. Vagueness does not mean wrong. I think vagueness means you're going to have a much harder time actually thinking about it and coming up with solutions. So instrumentally, it's very useful to clarify. But in terms of actual credences, vagueness is some amount of penalty, but it's not a huge penalty for me. And I do still think that AI alignment concerns are I'm not going to say Miri almost certainly going to happen, but a problem that more likely than not will need to be addressed. Like if humanity just completely ignored the alignment problem, which they wouldn't do even if long-termists weren't around. But if humanity just ignored the AI alignment problem, I think I'd give it like over 50% chance of some sort of existential catastrophe.
Okay. Gunnar Zarnicke asks, 2 questions about the threat modeling. How do you deal with the uncertainties and the needed extrapolation beyond known threats? Do you use a model that combines risks in a non-multiplicative way? The fear is that an AI could find a way to combine individual threats in a bigger one that is not the multiplication of the individual probabilities.
I think this is a different notion of threat model than the one I meant. So there's like, I am more interested in risk models that tell you why the AI is trying to hurt you. I think once the AI is trying to hurt you, then there's like a whole big variety of threat models for how the AI could hurt you. And I agree there. It is probably, I would feel much more pessimistic about an approach that was like, after the AI is trying to hurt you, let's like list out all the ways that it could hurt you and like try to prevent each of those. And I am not advocating for that. I am advocating for let's make the AI not be trying to hurt you in the first place. And there, I am less convinced that it is, what was the word? Multiplicative, maybe?
Yes. Mark Jackson asks, you use COVID as an example of a fast change being a threat, but what about slow change? Perhaps AGI leading to concentration of wealth in the hands of a few could be an example of a slow threat. So how do we decide how fast a threat has to incur?
I don't think I am actually very tied for it to the change being fast. It is just easier to argue, or it's easier. It's an easier example when the change is fast. But I think slow changes can also lead to distribution shift that's bad. I will note that, like, to the extent that I am most interested in slow change. Well, any kind of change happens, and because of that, the AI is trying to hurt you, as opposed to slow change happens, and that change in and of itself is bad for humans. I'm definitely thinking about the former for AI alignment.
Okay.
Without claiming that the latter can't happen. The latter could happen. I'm just not thinking about it.
Colin McGlynn asks, if you are training a reinforcement learning agent in an environment with other agents, wouldn't you expect some of those agents to attempt cooperation and others to defect? Is the idea that that isn't a threat as long as you never unbox it?
I mean, okay. Let me try and understand where this question is coming from. It feels very different from my ontology. I think the answer is yes. And like in the development model for DeepRL AGI, the hypothesis is yes, we're like considering AI systems that like that are not so powerful that they can like break out of the box, as it were. We're considering like AI systems that are like learning what cooperation and defection is. They're like figuring out, you know, how to do sort of reasoning about the other environments that are in the agent, other agents that are in the environment with them. But they don't really get very much information about the outside world. They don't obviously have like goals for breaking out, and so they don't try it very much, and so their skills don't develop in that way. So that's like not a very salient risk to me in that setting. But yes, they are learning both how to cooperate and defect with agents, and when you deploy it in the real world, maybe it then like defects against people instead of cooperating with them. I think if that were to happen, companies would notice it real fast and wouldn't even deploy these agents. So I'm not too worried about that case. But yes, that is something that in theory could go wrong.
Tomasz Gawenciak asks, what is your take on risks of multiple AI ecosystem embedded into human society? AIs that are individually weaker and narrower than AGI, but more capable as a system, as in the CAIS model. If at all, what would be your top risk story, including human or economic coordination issues?
Let's see. Okay, so I think in a case-like story, I am most worried about each individual AI system doing something that isn't what we wanted. It like generalizes in a weird way. And the emergent interaction of like a whole bunch of systems doing things that are not humans want leads to like a big impact on the world that's bad for humans in some way that like I can't really like. I'm definitely hand waving a ton over here. That seems plausible to me. But I don't think that I'd really buy. I am less into. I wouldn't say that like I would think of that as like a overall powerful optimize, like the aggregate of all of them is a powerful optimizer. I wouldn't think about it that way. I would think about it as like you let loose a bunch of like demons that individually were like not super powerful, but like all of them were wreaking havoc in society, and society just couldn't handle it. In the same way that I like, I wouldn't think of like all of the criminals together as like one massive, very intelligent criminal. I would think of them as like a whole bunch of criminals who are all wreaking havoc on society, and like we have to deal with all of them, and like dealing with all of them is harder than dealing with one of them. I don't think that was the entire question. What would be your top risk story? Top by what measure? Like the one that we can intervene on most easily at this moment in time would be like we build an AI system. The AI system does something that is different from what we want competently. And then somehow that leads to catastrophe. Like I definitely think that like intervening on the AI system didn't do what we wanted it to do. That feels like the key intervention point that we can do right now. But if you ask me to rank by like credence that it will actually happen or something, it's going to be something around human economic coordination issues is probably the broad category, though I couldn't really tell you what it would look like right now. It also could be like, geopolitical races for the best AI or something that leads to war, like no misalignment, just straight up war. That's AI enabled or something like that. Like there are a whole bunch of things. I don't really know. My like estimate on the not AI alignment scenarios tends to vary quite a lot. Like some days I feel like it's 1%, and some days I feel like it's 50%.
Quinn Doherty asks, how much effort should computer scientists who hope to contribute to alignment or existential safety put into threat modeling themselves? And I'm not sure whether to interpret that as whether they should be doing some threat modeling or whether they should be modeling their own behavior and the threat that they pose, but you can take it either way.
I assume it was, threat modeling and not for themselves. But I'll
Quinn
take it
is
that
saying
way.
it means what you're saying. It's whether they should be doing threat modeling.
I do threat modeling. I think it's very neglected on the margin, and for the specific threat of like, and then the AI system was trying to kill you, or trying to hurt you, or wasn't doing what we wanted. That's sort of if that's your sort of end goal where you go with the risk, I think that like that is a primarily technical question and not a sociological question. And so it's like specifically like good for computer scientists and AI researchers to think about that. They have comparative advantage at it relative to other people. I think it is probably also worth it for such people to then think about, and then how do those AI systems lead to the existential risk? And I do in fact do some thinking about that, but there it's like less obvious that it has to be the computer scientists versus other people. just at the moment, there's like, I don't know, 5 people that, okay, maybe not 5, but like it's not very many people doing it. And it seems like right now the stories need to be very tied to the story of how the AI system was trying to hurt you or stop trying to do what you want. And so like it's easiest for someone with a good model of that portion to then do the other portion, which says, and this is how it then like interacted with humans to like lead to an existential catastrophe.
Steve Burns asks, your utility maximizer threat model merges 2 things. A, AGI looks like a utility maximizer, with B, a programmer chooses the utility function. What about A without B? In other words, a utility maximizer with inner alignment issues, threat model. The classic development model for that is via self-modification, though there are others. Thoughts on this?
I don't see why self-modification should create a utility maximizer. Like, for example, if I think about what would happen if I got the ability to modify myself, I mean, first off, I would be extremely, extremely careful. But like, I don't think the like, let me write down a utility function and then optimize it would even like, I'm not sure I would even consider it for any sustained period of time. Maybe after like a whole bunch of self-improvement, at some point that makes sense. But like, I don't know. Like, I don't really see the argument for like why that's a thing that self-modification would lead to. Inner alignment, I'm on board with inner alignment, but that doesn't mean that the AGI looks like a utility maximizer. The Mesa optimizer story is trying to make this claim of why that AGI will look like a utility maximizer, and I just don't buy it. And I've written about why I don't buy it on the alignment forum. If you can look those up. Well, no, I haven't really written about it, but I've like at least made some like arguments about why the Mesa optimizer story isn't very great for making this claim.
Duncan Fowler asks, is there a meaningful difference between reinforcement learning AI and AI with utility functions? Doesn't the reinforcement create a de facto utility function? For instance, AlphaGo has a utility function based on maximizing the probability of winning the game.
Yeah, I agree that this is a reasonable thing to think given the way that it's theoretically stated, but just in practice, the way that reinforcement learning systems look, it doesn't seem to be true in practice. Like, they look like the reinforcement learning systems look like, they behave like utility maximizers for the reward they were trained on the distribution they were trained on. But also on the distribution that they were trained on, we see exactly what their behavior was, and we chose what they should do. And so they should be well aligned with us on that distribution. So it like seems hard to argue for risk from that perspective. But then, so like any sort of risk that you want to argue for has to come from like some sort of deviation between train and test. And in practice, when we take RL agents and we like move them off distribution, test them on something that doesn't look very much like training, they just sort of fail miserably for the most part. And so it's like they stop looking like utility maximizers very quickly.
Itamar Minuchin asks, in cybersecurity, you have hackathons to find vulnerabilities in systems. If you were to think of an AI alignment goal that is related to current research and possible to accomplish within a limited time frame, such as a hackathon, what goal would you go for?
Ooh. It's a good question. I mean, people could write down threat models. It's not exactly very hackathon-y, but that seems like a thing that people could like attempt in a short amount of time. It could also be that I'd be interested in like a version where like somebody trains an interesting big neural network, has the model, and then like there's a hackathon to like figure out something interesting about that model, how it works, or something like that. So if you've seen the circuits work by Chris Olah and the Clarity team at OpenAI, well, I think they're no longer at OpenAI, but they did a lot of the work while at OpenAI. Like they do a bunch of stuff about learning how how vision systems work. And they've put like thousands of hours into this. So I'd be curious what people can glean by just sort of staring at a model for like 48 hours. Can they learn something interesting? What were the techniques they used to learn those interesting things? And this is sort of from the perspective of like, it would be cool to learn how models, what models do and how they tend to generalize.
Ruben Falkovich asks, would a partial solution be precision-weighted actions? In other words, limiting the impact of your actions by how similar your current environment is to the environment you were trained in. Kind of like what we do when we behave carefully.
Yes, I think that to the extent that you can actually, yeah, I probably should have listed this on the like solutions for my risk model. There's a sort of general class of solution, which is like notice when you're being asked to generalize and then just revert to a safe baseline policy. Seems possible. I think there are like lots of there are some like, I don't know if they're big, but there are some pitfalls, which is like, how do you know when you're not on the training distribution and when you're being like, quote unquote, asked to generalize. But it feels like, with research, you could develop an adequate solution to this that adds some marginal safety. I sort of think like all of the things I listed are things that like add marginal safety rather than like saying, and now the AI system is safe.
Scott Owens asks, many national security analysts and AI experts see there's a potential for AI in military applications. Obviously, it would be ideal that nations do not use AGI for a war, but can this be avoided? Could AGI be used to avoid war? Do military national security officials understand the risk models of AGI? And if they do not, what should they understand about AGI?
Can AGI be used for war? To prevent war? Yeah, to avoid war. Seems, I don't know, seems plausible. I don't want to restrict, like, I don't have a particular idea of how right now, but like, man, sure sounds like if we really thought about it hard and put a lot of, if we threw a lot of like effort into the matter, or a lot of intelligence at it, it seems like plausible that we could find out some way to reduce the probability of war. One way is to like, if you can have credible commitments, which like plausibly you could with AGI, that can often lead to like more cooperation. A sort of central problem in game theory intersect politics is that it's very hard to verify whether or not the other party is actually holding up to their end of the bargain, and this makes it hard to make bargains. And credible commitments could solve that. Even if not credible commitments, you could imagine that it turns out that AGI is like makes it a lot easier to verify stuff. So yeah, so it definitely seems like that could happen. Do military leaders know about the risks from AGI? More so, I think, in the past year or two. So you can see at least some people in government. At least some people in government are like writing white papers and on like, oh man, like there are these neural network things, but they're really horrible at robustness. And like in order to meet like government standards for robustness, you'd need like a huge amount of research into it. And robustness is sort of like very, very adjacent to, it's like the superset of like good generalization. So that seems related, at least. Would they be able to tell you like any of the sorts of things I was talking about during this talk? Probably not. The development models, maybe, but probably not the risk models. But you know, I'm optimistic about the trend. I might have missed another part of the question. I don't remember.
Okay. Richard Pavlovsky asks, on what level do you think the threat modeling should be implemented? For example, personal responsibility of the research team or conferences to make it mandatory to provide threat modeling as a section in a paper?
I don't want the latter. The latter, like, my guess is it would incentivize like not very well thought out threat models, and it would then become like, you know, someone would write a like 2-paragraph threat model in a paper and everyone else would copy their threat model, and like we'd actually have bad threat models as a result because people aren't like, you know, aren't actually putting in very much thought into it. So the thing I want is like people who like spend 100+ hours on it or something. Like I want some people to like be like, this is my research project. My research project is to figure out this threat model and make the best case for it that I can, or like figure out what my credence on it is by like finding both evidence in favor and evidence against, something along those lines. As to like how that should be organized, I have fewer opinions on that. At least right now, it's just like whoever I can convince to do it, including myself, just does it.
Hey, Mayhew asks, can recursive self-improvement turn an AGI that we have a good development model for into an AGI that we have a good risk model for?
Possibly. I think, so I noticed a comment in the chat that says that recursive self-improvement probably supports like acquiring resources. And I think I agree with that. Like to the extent that something is doing self-improvement, it probably is going to be acquiring resources. I don't know. It feels like the important part is like, at what point did the agent acquire the like quote unquote drive to be sort of what we canonically think of utility maximizing, in the sense of like it's making long-term plans and like evaluating actions based on their consequences, and like not really taking into account the like impact on humans for those consequences, and it's being very agenty in some sense of the world. And I don't really like, it feels more like recursive self-improvement will be associated with those kinds of agents rather than causing those kinds of attributes. So I don't currently think that recursive self-improvement can fill that argument, but I'm not super confident about that.
We'll take about 2 more questions. And Jonas Andrulis asks, do you think about a scenario in which the threat does not come from the AGI, but from the fact that this technology makes humans more powerful and amplifies humans' mistakes, as the atom bomb amplified the human power to make mistakes? Do we have to limit what humans, companies, and states can do with potential AGI?
I agree that is a reasonable argument for existential risk. I don't think about it as much as I think about, you know, cases where the AI is trying to hurt you. But yes, that seems like a good risk model that we should probably address at some point. I think I'm optimistic that like our existing apparatus for dealing with these risks will continue to work. Things like, you know, regulations, governance, testing, monitoring, and so on. surveillance, maybe. I guess surveillance isn't really a technique we already use, but it's becoming easier to do. I don't, and but this optimism mostly comes from looking at the past and being like, things generally seem to have gone okay. Like not as well as they could have, but also like not the worst outcomes that could have happened. And being like, on priors, I should predict this continues to happen. I think there are like some good counter arguments to that line of argument, including like, well, our technology is getting more dangerous than it was in the past, I think is the biggest one. But like overall, I'm like, I don't know. My brain spits out optimism. I don't really have a sense for why.
Kun Holtman asks, there's a lot of work on building reinforcement learning agents using neural nets type Q functions. I interpret these as utility maximizers with utility defined by the reward signal. So I think we had similar questions. Would that fit into your model? Do you disagree, and why?
Yeah, I think I would give the same answer where I'm like, yep, it seems reasonable to model RL agents as utility maxes on the training distribution, but risk has to come from like changes to the training distribution. And empirically, in those cases, the AI systems still don't look like, the AI systems no longer look like utility maximizers.
Well, thank you, Rowan. Now is everybody's opportunity to unmute at last, so we can applaud.
Everybody also became visible.
Okay, thank you. Thank you. I enjoyed that. So we're going to continue now.